let's talk about mass spectrometry here. So mass spectrometry is usually a technique to determine what is the mass of the atoms or molecules in a sample. Sometimes you're going to be given a random sample of a product. We don't know what it is, and you're going to have to determine the mass of it just based on what you can see with a couple of measuring techniques. So for mass spectrometry, or sometimes in chem we'll say mass spec, we're going to basically excite a few electrons, and this will ionize, which means to separate the atom and release the electrons to count how much there is. An electric field will separate these ions, which are basically, we're breaking apart the atom. Just think about breaking something into pieces, and you're going to excite it to see what's the mass to charge ratio. The number of atoms at each M to Z value is then compiled into a data chart. So sometimes what we like to do is we like to literally zap things with a laser, or zap things into like a little cube to see how it behaves. And based on those behaviors, we'll be able to take the mass of something. So any questions there so far? We really like to excite things in chemistry a lot, just because we want to see like what we can visually see from it, and then we can determine an unknown from that. So, and here's just kind of an example of what could look like with natural copper. So here we see that we want to know the relative number of atoms of natural copper. And here we can see that we have copper 63 here, which makes up to 69% of all natural copper atoms. And then here we'll have copper 65 is another abundant one, but at 31%. And it can be written as a mass to charge ratio, M to Z, or mass number. So if we look, I'll later show you guys how to read out the periodic table. And from the periodic table, we'll be able to determine what the atomic number of that is. So any questions there? Okay. So here's another, this would be a sample question from the AP exam. This is actually from the 2018 AP exam. So say you were analyzing this nice mass spectrometry graph of atom Y. For the following, you can analyze, or we'll be analyzing the mass spectrum of compound Y, which peak shows the highest number of neutrons, and you would have to identify what it is. So here, of all of these, I believe we can see that C is the one with the highest, like the highest percentage, because it's the tallest, right? So if we just look at that, you kind of want to look for the tallest part of the graph here. And this one would be C, which has a mass number of 99. And then we also want to know, like, what's the smallest peak? The smallest peak will identify the atom that has the largest amount of neutrons. And if you really, really think about it, when you think about something that has a lot of neutrons, it means that it has a lot of energy, which means you don't really find it in nature. Like, we don't go out into a park or a forest and just randomly find carbon 13 or carbon 14, right? Like, it's not just something that you randomly find in nature. So when we think about identifying these neutrons here for this unknown, we want to know which one is the smallest one in this case, because it's like, which one am I not going to randomly find out there in the world? Does anybody have any questions here? Okay. So finding the compound line. Find the average atomic mass by adding all the masses with their percentages. So you would just do that. And I'll show you guys how to do that when we get into the advanced part of the course. If you calculate it, you will find that the answer is 96.3. And this is the mass of this really weird atom, or not atom, element called molybdenum. It sounds really weird. It sounds, I think it might be Russian if I'm not mistaken. So any questions there? This is actually just kind of a taste of what the exam could look like, but I'll show you the neat tricks here and there to kind of help solve it, okay? Composition of mixtures. Okay, so are you guys familiar with what a mixture is? Like, let's just say that you add water and oil together, or you add, I don't know, salt and water. A lot of the things we're going to be playing with when it comes to mixtures is often with water. So how would you guys define something that is a mixture?
That are combined together.
Yeah. And we know that mixtures can either be homogeneous. That's actually how you said it. I used to say it really funny before. Homogeneous or heterogeneous. We know that the prefix here for homo is the same, like Homo sapien, and hetero means different. And this is kind of a new word. Do you guys know what polarity is? Or have you ever heard of this word before? Like something that is considered polar.
I learned it in science last year a little bit. I kind of
Oh,
forgot.
cool.
Like when it's like attracted to each other, I think, because like water is.
Like water is a very polar molecule. That is correct. Yeah, great job. So polarity is essentially something to do with the energy of that atom. And in this case, if we kind of remember, or if we've ever seen how water looks like, there's a reason why it's called a polar molecule. So we're going to get into that because I think I have a slide dedicated to just water. So great job. Okay, so as Leo said, mixtures are a composition of two things that are mixed together. In this case, it's two or more elements or compounds. So it's a bunch of things that are mixed together. Elements are singular atoms. So an example of an element that we've been seeing is carbon. Compounds are combinations of elements. So think H2O, carbon dioxide, carbon monoxide, sulfuric acid. That's something I like to talk about a lot. And a mixture can either be homogeneous or heterogeneous. Most mixtures will often be heterogeneous if we think about it. Chemistry, a lot of the time we're trying to make solutions and we want to make sure that our solution doesn't really separate. So more often than not, we want something that to be on the heterogeneous side. So here's a flow chart. As I've defined matter, matter is anything that takes up space and has takes up volume or has mass. So matter itself, can you physically separate it? Yes. If you can physically separate something, meaning I can put like a strainer or a funnel on something and break it up, this is a mixture. If I cannot physically separate it, meaning break it apart or use a filtration device to get through it, this is in chemistry is what we call it a pure substance. Something that is pure is actually super difficult to break apart. Going back here to the flow chart of yes, it is a mixture. Is the composition uniform? So we both know, I'm pretty sure you guys know that water and oil will never mix together. And whenever we mix them together, oil's kind of like, get away from me. So it separates at the top. That is actually a heterogeneous mixture because it doesn't want to mix at all with water. It's just going to sit at the top. So for heterogeneous, think oil and water. They don't like to mix. A homogeneous mixture is a solution. A solution is really if you have two or three things all mixed together and they don't separate. So a common mixture or solution that I can think of is water and salt. Over time, there's this compound that I can make later, which is vinegar and baking soda, and it's called sodium acetate. That's called a solution. Anything really that has like two names in it is actually going to be considered a solution. Usually you're going to put things together and that makes up solutions. It's kind of the fun world of chemistry, really. It's making solutions. Okay, we're good?
I have a question.
Yes, ma'am.
So for the heterogeneous mixture, so like I think I've heard of like mechanical mixtures and stuff before. So would
Yes.
that, like be classified as like a heterogeneous mixture?
That's a great question. How do you remember the word mechanical before? Or like, because mechanical sounds like, or what does it sound like to you? Just to kind of, I'm not trying to put you on the spot. I just want to know how you defined it.
It was like, I think it was one where you could like physically just like separate it.
Yeah. Do you remember like yes, you can separate it, and in this case, that is a heterogeneous mixture. Actually, sometimes in chemistry and universities, we make up solutions, and then they want us to separate it completely to see how much of a pure part of it can come out of it. So yeah, sometimes you're actually going to make something, and then they force you to break it up again to see if it comes out the same as you measured it. So yeah, that could be classified as a mechanical mixture. Awesome. So homogeneous substances can be known as pure substances. They can be made up of an element or a compound. And a compound, we're going to get to know what a compound is later. Salt water can be an example of a homogeneous substance because it's made of water and salt and they mix together. We know that water and salt dissolve together, right? So you cannot see it for the most part. You will not be able to see the grains of salt once you mix it together. A heterogeneous mixture is composed of an element or a compound, but you can see all the elements present. So for the most part, you will not be able to see things become uniform. You're going to be able to see if there's separation, if things don't dissolve, like that's what that means. I think I don't know if you guys ever done the water and salt experiment, or not salt, water and sand experiment. But whenever you add sand to like a glass of water or like a glass of water, it just doesn't mix at all. It just sits at the bottom. And that's mostly because what's in sand is actually not soluble in water. Soluble meaning it doesn't mix at all. And actually it's because what's in the sand is what makes it hard for it to dissolve in water, which is why at the beach you see so much of it. Okay. Any questions here? Okay. Cool. Do you guys still need more time to write down stuff? Excuse me. All right. All right. So for the separation of mixtures, there's two ways to do it. The most common ways that we know in chemistry are distillation and filtration. So filtration, to me, what it sounds like, it's going to go through a filter. And I really, 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 really don't like distillation, actually. This one is a pain to do, in my honest opinion. To separate, if you make a solution and you have to break it up through distillation, it can take from 4 to 5 hours to break up into another pure substance. It's actually really hard to do it. So it's not my favorite. Okay. So for distillation means I'm separating the components from a liquid and evaporating it into the most reactive part of a substance. So the most reactive substances will have a really low boiling point. So meaning once it gets super, super hot, it's going to start to evaporate quickly. And whenever we're able to separate these substances, it's because they take different boiling points. Again, as I said, I don't like to do this experiment, actually. It's actually time consuming because you just literally stand in front of the machine, which I'll show you guys in a bit, and you wait for a little bit of liquid to come out at the other end. So you're just standing there for hours making sure that something comes out. And if it doesn't, it means that something happened and we need to figure out how to fix it. So it's probably the least fun that you'll have in a science experiment. All right. All right. Can I move on to the next slide? Sure. Okay. So this is actually what the device looks like. So you're often going to have this thing called a round bottom flask here. And you'll have like a Bunsen burner that's going to be heating up this glass. And inside the glass, it's going to be the solution that they told you to make. This is just a giant column called a fractionating column. And you will have a thermometer to see how hot this thing is getting from the inside. Often steam's going to be starting to come out. And over time, like whatever's evaporating will come out, and whatever's the most reactive thing will be actually coming down into this empty flask here. Often you're going to have a water in, water out kind of situation happening. And the reason for that is because we know that this thing is getting super hot, so you don't want to get it too hot to the point where the glass is going to start to kind of break up. So the water is just to kind of help it balance out so it doesn't get too hot to the point where it'll explode. That actually happened once, and it was actually pretty scary. Where I was doing a science experiment with some of my colleagues, and we kind of forgot to kind of keep the water running at a pretty high pressure, and it ended up breaking up and stuff started to fly. It's actually kind of scary when it flies because you don't know how to make it stop. So yeah, make sure that your entire setup is correct, because otherwise, yeah, it can be a little scary. All right, so any questions? Nope. Okay. I'll probably post some of these slides up too, so don't worry about like, oh, hey, I don't know how to draw that. It's cool. It's really hard to picture it. Okay, for the filtration, we're separating mixtures using a filter. So think like a funnel or something that you're going to push through something. And all you're really doing is separating solids from liquids. And this will only work if you have a heterogeneous mixture, meaning that the mixture is not uniform, something like a soluble, non-soluble thing formed at the bottom, like a white powder, something powdery formed at the bottom, and you just want to like make sure that you get the water out and to make sure that you can get as much powder as you can to measure it. Those can be a little fun and also not so fun. Actually, the only in university, you'll eventually make your own aspirin using this type of setup. And I actually had a professor who would make us do the aspirin, and he would taste your aspirin. He was weird. So yeah, I don't know why he would put homemade aspirin in his mouth. And I think he almost put one that didn't come out perfectly, and it turned yellow. And as you know, aspirin's white, so he almost put yellow substance in his mouth. So don't do that. All right. Any questions here? Okay, so it kind of looks like this. For the most part, we have these cool filter papers. The filter paper is, I would say, thicker than that of coffee, the coffee papers. And in this case, you want to pour much of the mixture into the funnel, and you want to catch as much of the residue as you can. You do not want any of that residue or powder to fall through the glass. If some of it falls through, your measurement will be a little inaccurate, and that actually will mess up your experiment results. I kind of like filtrations because mostly all you have to do is just focus on getting whatever powder carefully, and then it's done. So this one I think is the more fun than the distillation one. So any questions here? All right. All right, salt, sand, and water. If you were to use this filtration technique, which one do you think would get caught in the paper? An insoluble substance will not dissolve in water. So anything that doesn't mix with water is considered insoluble. So between the salt, the sand, and the water, which one do you guys think would get caught in the paper?
Sand.
Yeah. What do you guys think?
I think the sand as well.
Yeah. Chloe or Rain, what do you guys think?
I think the sand as well.
All right. So yeah, you guys are correct. I might have spoiled it actually early on, but yeah, sand will never ever dissolve in water. It just kind of sits. I've done this a few times actually. Or have you ever guys gone to the beach and you try to rinse off the sand and it doesn't really dissolve? It just stays on the ground wherever it is. That's essentially what it is, what sand does. No matter how many times you try to wash it off, it still stays stuck in places. So yeah. All right. So chromatography is another method of separating mixtures. This one is fun. This one can be done with Skittles or M&Ms. And it's mostly because we want to separate the colors that come out of the candy. Because we know that we didn't just magically make Skittles the colors of the rainbow, right? So chromatography is a method used to identify and compare the mixtures based on their attractions to solids and liquids. So it's basically how to separate the colors or what's in the color to see it. The reason how and the way that this will kind of play out is that polarity or the attraction of said substances is going to play a component to it. And polarity is formally defined as the distribution of electrical charge over the atoms joined by the bond. So we're going to talk about bonds later, but most definitely polarity is a big thing that plays a part in it. So when you think about polarity, think about, will things want to separate or will things want to stay together? And chromatography is you're kind of forcing it to separate. Like you want to break it up and see what is coming out of something. In forensics, this is done to kind of separate stuff that can be found in a crime case. Sometimes they use alcohol in this other solution to kind of see like what type of like liquid evidence can be found from it. It's kind of cool. Any questions here? Nope. All right. So this is called TLC or thin layer chromatography. So in this case here, what happened is that you have these two little dots here, and that's what we're starting with. And sometimes it's usually just like something like a Sharpie, or sometimes if we do like a Skittles experiment, you would put your Skittles here and you just add water to them. And what you want to see after 5 minutes or so is that you want to see how far the colors travel upwards. So it kind of just rises up, and you just have to wait on it for a couple of minutes. So the total is probably going to be less than 30 minutes. And you want to see how far the substance traveled. Oops, sorry about that. And sometimes they'll make you do this thing called the RF value, which is just the distance traveled by the component over the distance traveled by the solvent. And the solvent more than likely is either going to be water or some type of alcohol. So any questions here on this? This is just a type of like separation of mixtures. Like if I were to say I'm gonna have a quiz next week, I would just need you to name like the 3 types of separation I went through today. And you would just have to write them out. So the 3 so far that we have are filtration, distillation, and chromatography. So I may or may not ask that. So I would put a little star next to that if I were you.